Welcome to my Pixinsight Beginner series, where we now reach level 3. I assume you have already watched and also tried in Pixinsight the first two videos. The first one, Pixinsight is easy, where we really just started with the very basic processes. Then the level 2, where we added the easy suite. If you have not seen them yet, it might be actually a good idea to start with them and then come to this video. You find the two videos in this playlist. And also, if you have not seen that yet, it means most likely that you have not yet subscribed to my channel, and that's the perfect moment to do so to not miss any more of these Pixinsight videos. So please hit the button below. And with that, let's get going. Hey, this is View into Space. I'm Sasha from Switzerland, so grüezi miteinander, and thanks for watching my channel. As I already stated in the title, we say mostly goodbye to the easy suite because it's easy, but definitely not the best way to do things, and we add some more scripts which are superior to what the easy suite can offer. Let's look at what we had and what we're going to do side by side. As you can see, for the 5 first processes, nothing changes at all. And to be quite honest, nothing will change anymore. There is nothing that I would know that's doing these better than the processes that we already have. So the good stuff starts with step number 6, which is we change from easy denoise to NoiseXTerminator. And here, and only here, I will ask you to take some money in your hands, spend the money that is needed for the NoiseXTerminator, and you will not regret it. It's a quantum leap in noise removal, and I will show you that. The next thing we're going to do, we change from the easy soft stretch to the generalized hyperbolic stretch. And I know that is a word, and it is quite complex, but it pays off, and I will show you. HDR we leave as it is, but then we go to the easy star reduction and exchange it with Bill's star reduction. Bill's star reduction is something really new, just a few weeks old, and it's so much better than the easy star reduction. It's really a revolution, and I will show you. The curve transformation we don't really need anymore because we already do all that within the generalized hyperbolic stretch. But what we're doing now, I introduce you to the concept of masks in Pixinsight, and we create a mask so that in the next step we only sharpen the stars. And with that, let's stop talking and let's start doing. I see you on my computer again. And welcome to Pixinsight. So I chose M20, the Trifid Nebula, for this example. This is straight from the stacking. If I stretch it, it looks like this. What I already did to save time is do the 5 first steps because they stay the same, so you should already be pretty used to doing that. So I will close this, and this is where we are right now with the background extraction, the photometric color calibration, and so on. Again, this is not stretched yet. If I take the stretch away, it's just black. So the first thing that changes now is how we remove the noise. And if we're actually zooming in, you will see that there is quite some noise which we have to remove. So what did we do in level 2? We used the easy noise reduction. So what I will do now, I will create a duplicate. So they're now both the same. So with the clone here, I will use the easy denoise. Here we are. I leave the settings as default, and I'll just say run easy denoise. Okay, and here we have our denoised picture. Now I sped this up, but in reality, this took a whooping 14 minutes. This took more time than any of the other processes until now. So that's one of the problems with easy denoise. We look at it when we have actually denoised the other picture. And here we use the NoiseXTerminator. And I will tell you afterwards everything about it. But let's first just look how it performs compared to the easy denoise. So I go here to Process, Noise Reduction, and here I find the NoiseXTerminator. It's a very little window here. I'll leave everything unchanged and just throw it over here and let it run. And ladies and gentlemen, that was it already. That was live, real time, about 5 seconds or something like that, compared to 14 minutes. Now obviously, the crucial part is which denoises better. So let's have a look at it right now. So we will zoom in now here by the NoiseXTerminator. Let's now compare. This is easy denoise, this is NoiseXTerminator. And I don't know if you can see it in YouTube, but here there is still some noise there. This is not perfect. And here with the NoiseXTerminator, the noise is just completely gone. So I really wanted you to experience that on one side time-wise, but on the other side quality-wise. So now where can you find NoiseXTerminator? So this is the homepage of Russell Croman, who actually is the creator of NoiseXTerminator and also StarXTerminator. I put the link in the description below. So as stated, it's not cheap, it's $60. But I have two things to be said. On one side, if you buy anything only closely comparable, like for example the Topaz Denoise AI, you pay over $100. And on the other side, if you buy one script for the full price, you get then the other ones for a discount. The installation is easy. It's a script, so it's done in the same fashion as you have already experienced it with the Easy Suite. So the next thing we have to do is we have to stretch. And also here I believe that seeing is believing. And here what I'm asking from you is not money, but time. Because what I will introduce now to you uses much more time than the two very swiftly ways to stretch, which we have used until now. So what I will do now, I will now create two duplicates. So just that we can compare the different methods. And let's now go back in history. So the first thing we did was actually the screen transfer method. So for that, if you remember, we need the screen transfer function. Let's use this here. We're now taking the triangle, putting it down below. We're taking the triangle here, putting it here. It's getting white, that's actually good. And if we're now taking the stretch away, then we have actually our stretch done. So we have our number one. So for the next clone, we use the easy soft stretch. So we get here the window, looks good, it's about at the 25% mark. Run easy soft stretch, and here we go, it's stretched. And you know, that's really the great thing about these two ways of stretching. It's just so fast. So now let's see what I propose to you. Go to script, and there, if you have installed it, you will find the generalized hyperbolic stretch. Also here there's a home page. I will also put it in the description below. There's a clear description how you can actually install it. It's very easy. It's if you have done the Easy Suite, it's exactly the same. And this one here is for free. Tells you to select the image that we want. That's the one. And when we select it, it asks us to remove the stretch, which we allow. And you see it gets black in the background. And now just as a warning, if you now expect a button like with the other two solutions where it simply will stretch, this is not available. And if you expect it to be easy, it's not. Actually, there are videos available to explain this nice little window, which go about 3 times the length of this whole video. So generalized hyperbolic stretch is complex, and what I will show you now is a very high-level way which you can use. But if you feel afterwards you really want to use that, I would strongly recommend that you look some additional in-depth material about it. So we always start first with a zoom. We zoom in until we see the curve, which in this case we have to zoom in the full 200%. We go to the left side of the curve. Click so that we get this blue bar. And so we get here this number. You send the value to SP, just press this button, and you see it will be copied down here. That's the symmetry point. So off this curve, it actually shows where it will stretch the most. Then you take the local stretch intensity and put it on 8, between 8 and 10. And now you start stretching. And you see now slowly the nebula is coming. And for the first stretch, that looks about okayish. What we want to do now, we want to go in the image inspector. If you click here on the right, you see preview stretch. Click on that so that we get the preview. Now we just click on the stars. We can also zoom in here and just see that we get nowhere over 1. Now here we get more than 1, but actually you see before this already was blown out. So there's anyway nothing we can do here. It looks fine. Good. Once we have seen that, we can close that. We say create new mini image on execution so that we get a new one, and we click OK. It calculates it. Obviously now it's completely blown out, so we have to reset here. We have already now as a target view the new picture that it has actually created, so that's now already stretched. So now the first thing is we do a second stretch with a generalized hyperbolic stretch. We see now the curve nicely, so we don't have to zoom in anymore. And we take again this blue bar, but now on the right side for nebulas like this. We send again the value to SP. We're going here now a little bit softer by the 3. And now we're actually extending here the stretch factor very gently. So now the nebula comes much nicer. It looks about right, but we want to look at it with the image inspector. We'll have a preview. And again, we're checking here that even now we do not blow out our picture, except where it was already. If you see 0.91, that's still okay. 9.4, that's still okay. So we're still okay. We didn't lose any image information. So we're creating again another picture just for to be sure, and we click OK, and we get the second picture here. We're again resetting. So now we're not finished yet. Where it says generalized hyperbolic stretch, we change now to linear stretch. And the linear stretch is a stretch like you would do in the histogram process. So, but here we have much better functions. First, we take the low clip. What it means, if we clip, is we remove information. So when I go now in here and just change the number slightly, 0.005. You see what's happening? It's already getting a lot darker, and with me actually losing minimal information. So all I did is I said, go as far to the left with the curve that I do practically not lose any information. And that looks already very nice. With a white point, I don't want to go that far, but I can also now move the curve on the right side a little bit to the right. And you see now down here, it starts clipping. That's probably a sign that I should stop it, but that's nice. Good. So now I press for the last time here, OK, and I can close it. So we can close the other ones, we don't need that anymore. But now let's do the comparison. You've seen this was quite a lot of work. And we want to see now, was it worth it? Or do our fast and easy methods the same good stretching? So we start with the screen transfer function. And I think it's easy to see that there's a lot of things blown out here. There's so much more detail in the nebula than here with the screen transfer function. Also with the stars, they're way more blown out. So I think we can all agree that this here is better than with the screen transfer function. So now compare it with the easy soft stretch. I think where you see the difference best is up here in this bluish nebula, where we have actually a lot of this nebula here all around. It's very nicely how you can recognize it, while here it's there, but to a much lesser intensity. Also here in the nebula, it feels much harder what it has done with less details than here with the generalized hyperbolic stretch. So it might be subtle, but if you want to have the perfect stretch, then this is the way to go. This is at the moment, from a stretch point of view, the best you can do within Pixinsight. Another advantage is that while after the stretch you still have to work a lot with curves, here this is practically done now. Nobody says you shouldn't at the very end, either with the histogram transformation or the curve transformation, to the last bit of adjustments, but it's not needed anymore to the extent that you would have to do it with one of the other stretches. So we could do now some HDR if it would be needed. I feel it's not needed here, so we can go to the star reduction. Also here, let's compare the two methods, the old one and the new one. So let's also make here a duplicate. We use the clone again for the old method. So we go easy and we go easy star reduction. Here we are. We click run. Okay, and here is the result. It took quite a while again, but also the other method I will show you now is not without effort. But let's just see which one will look better afterwards. So I will just close this for a moment. So Bill's star reduction processes are processes, not scripts, and it's a bit different how you install them. You actually download a file, and I will also put the link in the description below. And once you downloaded this file, you just throw it on the surface here of Pixinsight. And once you do that, you will automatically get these four little windows, however you want to call it, on your screen. And that's it. And you will have to save that in a project that it will stay. Otherwise, you can always just keep the file somewhere, and when you need it, just throw it on the surface and they automatically appear. So, what do you have to do? First, you see here this one, clone for starless. So what you do, you take this one and you throw it on the picture. And what it will do a clone, and it will call it starless. The next thing you're doing, you're taking this clone and you remove the stars. You can use StarNet, StarNet++, or StarXTerminator. Given I have StarXTerminator and it's just the fastest way to do it, I will use that. Okay, and here we are. That's done. Looks pretty nice this way. We see now very nicely the whole nebulosity. We also see where my stars really suck, so that it didn't recognize them as stars, but it's good enough for what we need. Okay, so now we can actually simply minimize that. Important is that it's there and with exactly this name. And with that, we can now use these star reduction methods. So Bill has actually created 3 different methods, and it will be on you to figure out which one you like best. Method 1 is the most simplistic one, but I like it already. So what is interesting, you can actually double click and then the pixel math window goes open. So this is actually simple pixel math what's going to happen. And what is crucial here is the 0.15, because that's actually the factor that is used for the star reduction. So you can easily change the aggressiveness of the star reduction that you want to use. For the moment, we leave it, but we keep it open, and I'll just throw it in there. What you will see that it's very fast. It's already done. And what I can say now is, that's a little bit too much. So then I just undo that. And here we are again. And I can say instead, I only take 35. Let's just try it again. Much more subtle. So I can say this is now a little bit too subtle. So let's try it again. Let's go now to 30. And yeah, I still like the stars in there. I think they're nice now. So I'm done. So let's compare now this with the easy star reduction. I think it looks better. I think the stars which are still there have more punch, they're sharper. And what I really like about this new method is that it's so controllable. Here, but with easy star reduction, I always had a feeling that something's going to happen. I was not sure afterwards what really happened. I had no control over it. And here, I have the control. I can easily go up and down until I feel for the respective picture it looks perfect. So we have done the star reduction. What's left? Now the last thing we want to do, we want to sharpen the stars a little bit. But the problem is that if we don't use a mask, then we also sharpen kind of still any noise, any residuals in the faint nebula. And that might actually rather do something destructive. So that's why we're actually, while we're creating now a mask. And you will see it's quite easy. We go to Process, and we're looking for Range Selection. What you do is you activate the preview. It would be originally completely white. And so you're actually homing in until you have the stars still white, but as much as the non-stars black. You also can introduce a little bit of fuzziness, of smoothness, so that you don't have any sharp edges. You might still have then to correct a little bit the mask again. And if you feel it's good, you just activate it, delete the preview, and here we have our mask. So how we deal with a mask? It's quite easy. You just take it here on this left thingy, and you drag and drop it into the picture that you want to have the mask on. And you see what's going to happen. You should not close the mask, you can minimize it. So you see everything that's now not red is still active. Everything that's red is protected. So now we can actually go to our unsharp mask. We can open the preview, because with the mask on you would anyway see nothing. And now we can, as before, start to figure out. You see it if we click now on preview on and off, we see the effect that we're having. So that still looks nice, also from an envelope point of view. Let's go a little bit more intense, 3. Still acceptable. We get some nice little stars again. I think that's about good. We can also check here the ringing, which has kind of a good effect here. So we can actually use that. Then we apply it. And the sharpening is done. Closing it down. We're closing the preview down. Now we go in mask and we say remove mask. It looks already really nice, but as stated, sometimes it makes sense now as the very last thing to go into the curve transformation tool again. We're also going into preview. There's 2 things we might want to do. The first thing is we might want to see if we just want to, for a little bit, make it a little bit darker without clipping too much away. And that's very individual. Some like it rather bright, so that nothing is clipped, nothing is lost. Some like a little bit more blacker, punchier background. I think that's about okay. So I will apply that. Now I will go back here. And now I go to saturation and I will just add a tad more color. I think that's good. We don't want to overdo it, but a little bit more color might be okay. So, and this is now the final picture. And with that, our process is at the end. Okay, and we're at the end of our process. I hope you could follow along, and I hope you like the result that you got from it. Now I know you're probably asking, so where do we go from here? Is this now the end? Is that it? Or is there a level 4? And my answer would be, if you want to process the whole picture in one go, then that's almost it. There are some tiny things which you can introduce, like deconvolution, but in principle, what you have now is a sound process which delivers great results. But if you want to go beyond, there are two things you can do. First of all, you can rip the stars and the nebulae apart and process them separately. This will allow especially for a much better star quality. And I will record a separate video about that. And then the other thing is, even when you make photos with a one-shot color camera, if you're using narrowband filters, you can actually rip the channels, the HA and the O3 apart and process them separately. And again, this brings you to a whole new league. And we will also look at that in one of my later videos. If you like this video, please give it a thumbs up and press the subscribe button so that you stay on top of it. See you next time. Clear skies.